Okay. Pour the powder in the bottom of the test tube.
There.
Okay. Now, add a couple of drops of water.
Okay.
See what's happening?
Beginning to bubble.
Yes. Okay, you want to put the water down, because we'll let the test tube fill up, and I'll light this punk. Meanwhile, I want you to tell me about oxygen.
Well, oxygen is very important to us because we breathe it.
Mm-hmm. Where do we get it?
From the air, because oxygen is a very special ingredient in the air.
Mm-hmm. It's also a special ingredient that makes fires possible, because that's what oxidation means. Something is combining with the oxygen in the air.
Yeah.
Okay. So whenever you see something burst into flame in normal life, you would know that it's getting a good supply of oxygen. Here's a glowing punk. What we have just done is put water on top of that powder, and that's a sodium peroxide, and the water releases oxygen. Here, put the glowing punk in the top of the test tube.
Wow.
Blow it out again. Just keep doing that.
Pops.
Yeah. See, because when you hold the punk in the air, it doesn't get enough oxygen. When you put it in a pure supply of pure oxygen, why, it gets enough to burst into flame. In fact, that's a sort of standard chemical test for oxygen. If you put a glowing splint in a gas and it bursts into flame like that, you know that it's oxygen. Okay? Keep the glowing punk and come around over here to the other side where I have a piece of white paper. Now, you can get another supply of oxygen from a chemical called potassium nitrate. By the way, you shouldn't try any of these at home because of the fire, right? Okay. In this case, I dissolved the potassium nitrate in water and used it as a paint to paint on this piece of paper. What do you see?
Nothing, just these dots.
Yeah, black dots. Well, I put those black dots in the middle of a trail. Touch the glowing punk to that black dot right there. Now give me the punk, and I'll start one over here. Now, you see what's happening?
It's making a trail.
Yeah, and notice the paper itself isn't burning because it doesn't get enough oxygen from the air, but because of that supply of oxygen I painted on it, it's now burning only in the trail where I painted. Touch the other dots now. Some people make horse races out of these, and they burn along through the paper, you see, and the one who gets to the other end wins. But the important thing for you to remember is that anytime you see something sort of burst into flame, you can be pretty sure that it's getting an extra supply of oxygen. In this case, making the paper burn. I assume you've seen one of these before, Angela?
Yeah, that's the middle of a paper towel roll.
Mm-hmm. Notice I have cut it with a razor blade around those spiral lines that are like that, because I want you to open it up. And then, but before you do, decide which of these three figures it could possibly be. Sort of a puzzle in conceptual geometry.
Well, this one's a rectangle, and I know that because these two sides are parallel, and these two sides are parallel. They all have 90-degree angles.
Okay.
This one's a parallelogram because these two sides are parallel and these two sides are parallel, but they don't have 90-degree angles.
Mm-hmm.
And this one's a trapezoid because these two sides are parallel, but these ones aren't, and they don't have 90-degree angles either.
Okay, so which is it going to be when you open the paper tube? Parallelogram, rectangle, or trapezoid?
I think it'll look like the parallelogram.
Okay, go ahead. Open it up. Put it right down here. Turn it over once so we can get it flat like that. All right. What is it?
Well, these two sides are parallel. These two sides are parallel, so that means it's a parallelogram.
You are absolutely right.
Yeah.
Very good. This plane is on an unusual mission. A bomb run in the Rocky Mountains of Colorado. The target is that lake down below. The pilot, Wayne Russell of the Colorado State Division of Wildlife, starts his dive.
He has to be about 100 feet over the water and flying no faster than 80 miles per hour. Then, bombs away. What falls to the lake is a fine mist. The bombs are living fish, greenback trout that have been raised in a hatchery. Because there are no roads in this remote area of the mountains, the only way to stock the lake is with a fish bomb run.
Jennifer, I'll push the button and you watch what happens to the bird now.
He's fine. He's going down to get a fish, and now
Right.
he's flying up again.
All right,
He's still flying.
still flying. Now, the question is, how come a bird can fly? A lot of people have wondered about that because it looks like he's sort of, well, maybe rowing through the air.
It does.
Or swimming or something. In fact, you remember way back in the olden days, the inventors even tried to put wings on people and they flapped them to try to fly.
Yes.
But it didn't work too well. So let's investigate how come a bird can fly. First, you remember this simple experiment. Yeah, you blow over the top and the paper goes up. Why?
Because you're lowering the air pressure at the top, and it stays the same at the bottom, so it just stays
It pushes it up, right. Now then, when you do the same thing with a little piece of paper shaped like an airplane wing, which is what this is. Blow over the top of that.
It does the same thing.
Same thing, right. And the shape is very important. Thick at the front,
Like
sort of
a
tapering
wing.
back like this. Okay, here is a bird's wing. This is the wing of a pigeon. And if you look at it sort of sideways like this, if I hold it, see how it's shaped like a wing. Isn't
Yeah,
that
it's
amazing?
like-
That wing
it
should be
is a
shaped like a
wing.
wing? Yes, it's a wing. Well, as the air goes over the top of the wing, lower pressure here, that makes the lift. So all the bird has to do is fly forward.
But how does he go forward?
That's the big question. How does he go forward? How does an airplane do it?
Well, it's propellers.
Yes. As the propeller goes around, what happens?
It lowers the pressure, and here it lowers the pressure, and here it pushes it.
Because this is the
forward.
same thing as a wing, except it's this way, and as it goes around, lower pressure here, and it's pushed forward. Well, take a close look at that bird flying again.
Okay.
But this time, look at the wingtips. Okay, first I'll back them up. Goes back up. There, now let's have him go forward and take a good close look at him fly. Here he comes.
He's going to pick up the fish again. He's got
Okay,
it.
now watch him as he comes around towards us right about in here. Watch. I'll slow it down. I'll go one frame at a time.
All
Watch
right.
the ends of his wings. Did you see anything?
No. They're like fingers, about 5 or 6 of them.
Yes. Now see his left wing? Now watch his right wing. See him?
Whole bunch of little fingers.
Yes, a bunch of little fingers. Well, you call them fingers, I'll call them propellers.
Okay.
That's exactly what they are. The wing-tip feathers act as propellers and pull the bird through the air just like an airplane does. So that's what makes a bird fly. Scott, see, here's a piece of paper, measures 8.5 by 11 inches. One plain old piece of paper. What we're going to try to figure out how to do is to cut holes in it so it looks like that.
But wait, that's impossible because there's a hole there and a hole there, but there's no cut down here.
Right. Now, the reason why it looks impossible is because of the way you sort of think about things. You're making the assumption that this surface and that surface are both the same, and this surface and that surface are both the same. And that's one of the things that in science you have to sort of prevent yourself from doing. Don't jump to conclusions. And I've done that in a special way to make you think that. Now, I'll give you a clue. Look at this one. Here is the same sort of piece of paper, right? But on one side it's plain, and on the other side it's got stripes on it. If I'll turn my back and make a few little adjustments and come back, that should give you a clue. Take a look at it now. What do you see?
Well, this side matches this part
Right.
because they're both blank. And if you turn it around, this part matches this part because they're both straight.
Okay. So that means that surface and that surface are what?
They're shifted around. They're not
Two
the same.
different surfaces, right. So how are you going to do that then?
Yeah, well, it looks like you'd have to turn it upside down.
Somehow.
Yeah.
You have to flip this. Okay, here's how you do it. You get a piece of paper like that, and I've drawn, you draw a line sort of down the middle like this, and then cut it from there, and then make these two lines like this, and cut where I have it dotted. Go ahead. Cut
Okay.
it. Notice you're making all the cuts on the same surface. 1. 2. 3. Now along the solid line, make a fold. Bring this piece up and fold it that way. Okay. That's kind of the normal way. You say, hey, that makes some sense, right? Now, what did you say we'd had to do with one surface?
Turn it upside down.
Okay, turn one surface upside down. Now fold it the other way. And there you are. Right?
Impossible holes.
Impossible holes. Congratulations. You just made 2 impossible holes. Have you been to an art show in a gallery?
Yeah, where you walk around and look at all the pictures.
Yeah, and sometimes you have a program and you look
Yeah.
at the artist's work. Well, I'd like to invite you to a private showing of my own artwork.
Your artwork.
There it is on the refrigerator. I don't have a catalog yet or any kind of descriptions, so you'll have to use your own imagination. The one on top is the only one I think I really have a title for, and that's Thin-Nosed Moose.
Yeah, I can see it here with the antlers and everything.
How about the green one over there?
That looks like a sea anemone with all the tentacles.
That's not what I had in mind, but I'll take your word for it.
Okay. This one looks like something, from your spinal cord.
Yeah. Then this one I do think sort of looks like a highway engineer who couldn't make up his mind.
Yeah, I can see that, when
Right.
all the roads are going nowhere.
Here's my primitive period.
Smiley face.
Smiling house. Well, it's a happy household.
I like that one.
You like that one? You like that one best?
Yeah.
Well, after you're smiling at my artwork, I think it's time for you to try your own hand at it. Here's what you do. The reason why we're doing this is because it's based on a scientific principle. You know that your mother uses bleach in the wash, doesn't she?
Yeah.
Why does she do that?
To make the clothes whiter.
Yes, to make the clothes whiter. And most people think, well, you put a chlorine-type bleach in, it comes in a bottle like this, and they think that the chlorine does it. But the chlorine really breaks up the water. Do you know what the formula for water is? H2O?
Oh, yeah.
H2O.
I know that.
That releases the O part, the oxygen. And it's the oxygen that actually does the bleaching. So you can use it on construction paper. Here's a piece of construction paper. Here is some bleach. And here are your tools. Paintbrushes, swabs. You can use fingers or anything else you want. Go ahead, put it on there once and see what happens.
Okay, I'll just make a little dot.
See how quickly it changes color?
Yeah, it's turning lighter.
Turning lighter. That's because the oxygen is released and it's making the green part into a colorless compound. So go ahead, you can do better than a corner, I think.
Yeah, I know.
You have anything in mind as you're doing this?
Yes.
You do?
Yeah.
You're going to see if I can guess it?
Yeah.
P,
No.
an igloo?
No.
No?
It's going to be sort of hard.
Sort of hard? A mushroom?
No.
I know.
What?
An octopus.
No.
No, only
It's-
4 arms so far.
It's sort of like an octopus.
Sort of like an octopus?
And it's got little things up here.
Little things like that?
And it's jolly.
I give up.
The jellyfish.
It's a jellyfish. Ah, I was right. Anyway, you can have a lot of fun. You try the various colors because not all colors will bleach. I found this brown and the green and the purple and whatnot are best. Some of the colors don't bleach at all, but you can use this scientific principle of releasing oxygen from water in order to do bleach art. Do you mind if I add this to my collection?
Nope.
Okay, I'll put it right here. And I must say, I don't think it looks any better than mine. You've heard the wolf in sheep's clothing story. Well, here it is in the insect world. What look like balls of wool are the so-called woolly aphids, small insects that suck plant juices. Ants milk the aphids for the sweet liquid they excrete and attack and kill any insect that might prey on the aphids. But hidden in the picture is an insect that eats aphids. It's an unusual example of a predator that disguises itself as its prey. If you have trouble spotting it, so do the guarding ants. But there it is right there. The insect wolf in sheep's clothing, the lacewing larva that has covered itself with wool from the aphids to fool the ants and safely eat aphids. Simple request, Tanis. Get up. Go ahead, get up.
I can't get up.
Yeah. I'm holding you in place with one finger. That's based on a sort of trick based on center of gravity. But before we go into that, here's another one. Here, get up. Okay. Come over here and stand. Put your feet against like that, your heels, and stand up tight like that. Now, without bending your knees, pick up the little red bell.
I can't pick it up.
There are two tricks based on center of gravity. Have you ever heard of that?
Yeah, I've heard of it in school.
Okay, what is the center of gravity?
The base of where you're standing or where something is.
Something like that?
Yeah.
Well, maybe we ought to really take a good close look at it so I'm sure you understand it. Here is a block of wood, see? Black. And here is its center of gravity. It's an imaginary point where gravity seems to be pulling down on the whole block.
Oh, I see.
And I have a string tied to this point at the center of gravity going down here and a weight down here that is pointing toward the center of the earth. It's called a plumb bob. Now I'm going to pick up the piece of wood that the block's sitting on, and you watch when it starts to fall in relation to the string and the base.
Okay.
Here we go, watch.
It falls just as the line passes the base.
Right. So something is in balance as long as its center of gravity is supported.
Yes.
And in this case, by the base. Now, you have a center of gravity, too, an imaginary point someplace about there on the other side of your stomach. And how come you're not falling over?
Because my feet are holding me up.
Right. That's your base in this case.
Yes.
And when athletes want to be prepared, not be pushed over easily, what do? They get down like this.
Yeah,
See,
make
they're
their base wider.
Base
so
wider.
they can be sturdier
You're
so
right.
they don't
So they can't be pushed over as easily.
Yeah.
Okay. Now that you get that idea, go over and sit down in the chair again.
Okay.
Okay. Now get up. Okay, do it again slowly and watch what you do with your body. Where is your base now?
Right where I'm sitting.
Yeah, and where do you want to put it?
On my feet.
The center of gravity is going to change from the chair to your feet. Now watch,
Yes.
very slowly. Watch what you do.
I lean over so I can get my base, the center of gravity to my feet.
Over to your feet.
Yeah.
Okay, and then sit down again. How come I can hold you in place with my finger?
Because I have to lean over to get up, and
Right.
I can't get up when you're holding me.
Who are you going to try this one on?
My brother.
He's 18, though. He has good, strong stomach muscles. Maybe you better
Yeah.
do it like this.
Okay.
And good luck. I hope you can get it. Here's a frontier in explosions. Watch the bottom of the rectangle. The lines moving upward indicate the pressure traveling toward the other end of the rectangle, which is actually a cross-section of a cylinder in which the real explosion took place.
The colors indicate the various levels of pressure. The whole thing was over in 15 millionth of a second. So scientists at the Los Alamos Scientific Laboratory produced this computer model of the changes in pressure to study the explosion in detail. With the data in the computer, it's possible to look at the explosion in 2 dimensions like this, and also in 3 dimensions like this. The same waves as before move toward the other end of the cylinder, but this time the height indicates the amount of pressure. A frontier of science, using a computer to graphically model processes, including a split-second explosion inside a cylinder.
Kristen, have you ever put out a fire?
No, but I've seen my parents do it.
What happened?
Well, there was a fire on the oven, and my father got a fire extinguisher, and he sort of played around with the top, and then this sort of white powdery stuff went onto the fire, and then it sort of died out.
Yeah. That probably was sodium bicarbonate, baking soda, because when you heat that up, some carbon dioxide gases give off, and that puts out the fire. And I have some of that very same white powder dissolved here in the water in this jar. Okay. Now, we're going to add this eventually. Smell that.
Vinegar.
Okay. You want to pour it in the test tube?
Okay.
Now put the whole test tube and everything right into the water like this.
Like that.
Okay,
Okay.
right. Now notice they're not mixing.
No, because you got the surface of the test tube
Right.
blocking
It's
it
keeping
off.
it separating. Now if I put the stopper on good and tight like this, the fire extinguisher is ready to go. See the paper at the other end of the table?
Yeah.
I'm going to go light it. Then I want you to take this fire extinguisher as soon as you think you're ready, turn it up and down, shake it vigorously a couple of times, and point this little nozzle right at the fire. What should happen?
The vinegar
Sodium,
and
Sodium bicarbonate.
will mix and form a gas, but the water will block it off, so it'll come out as liquid.
As long as you keep it turned down this way so that you keep the other end of this stopper covered with water. Okay, are you ready?
Yeah.
Okay. You want to go round about over there. I'll light the fire. That's a problem. This is one you ought not to try at home unless your parents are around because you're using fire. Anytime you're ready, Kristen, give it a blast. Okay, and hold it up high like this. Get your hand around on the other side. There you go.
Should I do it again? Should I?
Yeah, give it another push. There you go. Now you'll get another blast. Beautiful. Okay. Well, congratulations. You've just put out your first fire with a fire extinguisher.